Hey everybody, welcome back. So today we're going to keep going with law of sines, and today we're going to talk more about the ambiguous cases, which happens when we have a triangle and we're giving an angle and two sides. And of course that's when we get ASS, which you can remember is a bad word, which means it's going to be a lot of work for you. So when you have a triangle and you're given one angle and two sides, you basically have three possible situations. You have possibility of having no solution at all. In other words, a triangle does not exist, and that's when you're solving for your angle and you get the sine of an angle is greater than 1, and you can't have that, so you'll get no solution. You can get a triangle where you only have one solution and only one specific triangle exists, given that angle and those two sides. And then the ambiguous case, when you could get two possible solutions given the angle and the two sides. But remember, we have our law of sines that's setting up our proportions between our angles and their opposite sides. Again, just a reminder, be sure your calculator is in degree mode. That causes all kinds of issues when it's not, so make sure it's in degree mode. So let's walk through each type of scenario. So the first one is when no triangle exists. And we'll have a situation when no triangle exists when the opposite side basically is shorter than the height. So there's a couple of different ways that you can do this. I think the easiest way is just to set up your proportion, and if you get the absolute value of your sine B is greater than 1, you just know there's no solution. And if we work these problems in these two different examples, you'll see what I mean. So in our first example, when we're given our triangle ABC and we have two sides and one angle, we get angle, side, side. So let's set that up. And so we get sine of 20 degrees all over 4 is equal to the sine of B all over 16. We're going to cross multiply, solve for the sine of B, and this is when we know we won't have any triangle that can work because the sine of B is greater than 1. So we get no solution. So now if we do the same thing for our other triangle where we have an obtuse angle of 120 degrees and then two sides, let's go ahead and set that up. So when I set up my proportions using the information I'm given here with my triangle, and I'm going to cross multiply, and I solve for sine B, and I get sine B is greater than 1. So again, I know I can't have a triangle, I get no solution. In our second scenario, we have three ways where exactly one triangle can exist. So when we're given one angle, two sides, and the angle we're given is an acute angle, we know only one triangle can exist if that triangle ends up being a right angle. So the side opposite angle A is actually the height of our triangle, and angle B in this case would be 90 degrees. Or if the measure of angle A is less than 90 degrees, so it's an acute angle, and A is greater than B. So if A is greater than B, then I know that angle A has to be greater than angle B over here. And that's going to restrict us to one possible triangle. And then the third way, which is the nicest situation to have, because it's always very obvious, is when you're given angle A and your angle A is an obtuse angle. So when it's greater than 90 degrees, then if A is greater than B, as long as A is greater than B, A obviously, if it's an obtuse angle, it has to be the largest angle in our triangle, and therefore only one triangle can exist. Now, if you're given side A that's shorter than side B, that wouldn't make sense. It wouldn't form a triangle, so then you would get no solution. Okay, so in the next example, let's look at our requirements because I'm realizing there's a mistake on here, right? Because the only way we can know that we have a triangle where there's only one solution is if A is greater than B. In this example, A A is clearly less than B. So I'm going to change the number here, and let's make A 75. And then it'll work out nicely, and we can use this one as our example. Otherwise, we would end up, this is a situation you'll see in the next scenario where we actually could get two different solutions. So let's go ahead and we'll set this up. So now when we work it out with our new numbers, we get angle B is equal to about 14.46 degrees. And we'll come back to this one after I do the situations where you have two possible triangles, and I'll explain to you again why we can only get one triangle in this situation. And then in our third situation here, remember our example, we're given one angle, but we're given an obtuse angle. And in this case, we always know we can only have one possible triangle. And again, I'll come back to these right after we work on the ones where we can have two cases. So now the ugly scenario, scenario number 3. So we could get two triangles when we're given the measure of angle A, and it's acute, so it's less than 90 degrees, and side A is less than side B. So let's look at how that can happen. We can have an angle A is the same measurement in both situations here. Side A is the same length. Both are 12, and we're given side B, but what can differ is the measure of angle B, and that's going to throw everything else off. Sometimes it's easier to picture if we look at it all with the two triangles on top of each other. So we're given angle A, we're given side A, which we said is the same length in both triangles, and we're given side length B. And you can see how side A could swing this way, making B an obtuse angle in the first triangle here, or it could swing this way, making B an acute angle in the triangle here. Have this situation, we just need to be aware of it and know to check for two triangles, and really the rest of the process is pretty simple. How in the world could we possibly get two angles that could satisfy our conditions? Well, think about it. If you go back and look at your unit circle, and let's say we're only looking for angles that go from 0, they have to be greater than 0 and less than 180, because we're talking about angles that can fit into a triangle. So if we're trying to find an angle B that satisfies sine being equal to 1/2, so we want to find the inverse sine of 1/2, what angle do we get? Well, we have between the values of 0 and 180, we're looking at all the angles in the top half of our circle here. And if you recall, if we look at our sine, we would have 30 degrees would satisfy that. And then we would also have 150 degrees would satisfy that requirement. So we would get two angles for B. So B would be 30 degrees, or B could just as easily be 150 degrees. And we really don't know which is which, and both might work. And that's basically what we're looking for in our triangles here. So back to our triangle examples here. So when we work this out, and we're using our information we were given, we solve for B, and we get B is equal to 64.78. Well, as we just saw, it's possible that we could get a different value for B. So we also need to check 180 degrees minus that value. So when I do that, I say, okay, well, I could get a second B that's 180 degrees minus 64.78. Gives me 115.22 degrees. So if I reference this formula up here, what I want to do is see if I use 115.22 degrees with the other angle that I've already been given, 20.5 degrees, can that work out to make a triangle? So in fact, it can make a second triangle because 115.22 plus 20.5, which is what I was given for angle A up here, is less than 180. So I can get another triangle that has the angles 115.22, 20.5, and 44.28 degrees. And then I would go on to solve for my remaining sides, side C, using the law of sines like I've been doing this whole time. And so you'll see in this situation I end up with my three parts for my first triangle, angle B1, and then I got my first option for C, so angle C1, and then side C. And then I also have my second triangle as well. So it's a lot more work, but the process is actually pretty straightforward. So just remember, whatever the problem is, always draw and label your triangle first. Set up your proportions using law of sines with your sides and your opposite angles, and then check for special cases. If you have angles side side, you could get a situation where you get no solution when you get the absolute value of sine of B. So sine of B is greater than 1, or it can be -2, so less than -1. That would tell you that there's no possible triangle that exists. And then if you have two triangles, when you subtract your second B angle from 180 to get your second option, if that can be used with the angle you were given to make a triangle, in other words, when you subtract angle A and angle B from 180, if you're still left with a positive result, then you would get two triangles. And that's the situation when you need to solve for, you'll have 6 parts that you'll need to solve for. So, well, three angles in each triangle and 3 sides in each triangle. So here's an example. Why don't you try this one, pause the video, and let's see how you do. And here's your solution that you should get. So we should get 2 possible triangles here. When I solve for y1, I get 54.78 degrees. If I subtract that from 180 degrees, I get 125.22 degrees. So that would be my second possible value for y. When I subtract 125.22 along with the angle I was given, which was 31 degrees, then I would get z2, my second z value, which is 23.78. And since that works out to be a positive angle, 23.78 plus 125.22 plus 31 add up to 180 degrees, so they form a triangle. So I know I get 2 possible solutions. And again, I have my values for side 1, z, y1, and z1 angles. And then I also have my values for the second triangle. So I have my second side down here, and then my y2 angle and my z2 angle. And again, this is another example too, where not every triangle will be labeled triangle ABC. So you need to just set up your triangle, draw it out, label it with the letters opposite the appropriate angle. I know it's a lot of work, but don't get tired. Try one more, see how we do on this one. Pause the video and let's see how you do. So how did you do? You should get only one triangle here. Even though I drew the triangle, like I typically do, that's an acute triangle, since we have an angle here that we were given that's greater than 90 degrees, remember that since A is greater than B, or in this case, Q is greater than R, and it's an obtuse triangle, I know I'm only going to get one triangle. If it makes you feel better, you can actually do the check here though too. So solve for R, we get 17.28 degrees, subtract that from 180 degrees, I get 162.72 degrees. But when I try to use 162.72 degrees with 98 degrees to make a triangle, obviously that's going to add up to be more than 180 degrees, so that wouldn't work. And that's another way of checking to know that we can only get one triangle. Last one for the day, and if you can get this one right, we'll consider us all experts and feel pretty good about things. So give this a try, pause the video, and let's see how you do. So how'd you do? When you solve for angle A and we get sine of A is greater than 1, we can just stop. We have no solution. So we can stop there. If you go back now and look at your rules that we started with, now they'll make a lot more sense. So in our last problem, we got no triangle exists, and that's exactly what happened here. We have A was less than B, and so given an acute angle, so it ends up being a situation much like this first one. In the second problems that we did, these are all the situations where we know we're only going to get one triangle. That second example we did was this one, where our angle is greater than 90 degrees, so it's an obtuse angle, and A is greater than B. And then remember, the situation when you can get two triangles is when you're given an acute angle and the opposite side of the angle you're given is less than the other side. So in this case, side A is less than B and angle A is less than 90 degrees. So if you got all those problems right, then you're now an expert with law of sines, and we're probably ready to move on to law of cosines next time. Have a great day.